Hello everyone. Today we are going to cover multiplexer. Multiplexer is nothing but many to one. In case of this, many inputs, one output will be there. So out of many inputs, we'll be selecting one input, given it as an output. So it is also called as data selector because data will be selected based on the select pins. For example, if we see some of the multiplexers, here we have 4:1 multiplexer and 8:1 multiplexer. In case of 4:1 multiplexer, we have two select pins. Based on these two select pins data, the input data will be selected, which will be given to the output. Similarly, for 8:1 multiplexer, we have three select pins. Based on these three select pins, any one of the input will be selected, given it to the output. And if you see here, we have a enable pin which will be used as a enable for your multiplexer using a logical 0. Next we will see applications of multiplexer. Some of the applications of multiplexer is half adder using 4:1 multiplexer. If you see the truth table of half adder, when AB is an input, we will get sum and carry. For the example, if A is 0, B is 0, sum will be 0, carry will be 0. Similarly, if you take it up 0 1, sum is 1, carry is 0, 1 0, sum is 1, carry is 0, 1 1, sum is 0, carry is 1. So if we design for a sum, the sum value is high for when A is 0 and B is 1, and when A is 1 and B is 0, that time sum is high. So for these two cases, we'll be setting it as a logical 1, and other two cases we'll be setting it as a logical 0. So if we take it up 4:1 multiplexer, we have four inputs, that is D0 to D3, and based on the select pin, each one of the input will be given it as a output. So if it is 0 0, in case of select pin, D0 will be selected, 0 1 D1 will be selected, 1 0 D2 will be selected, and 1 1 D3 will be selected. So based on that, if you see, sum has 1 as a high output, 2 as a high output. So we are setting it as D1 and D2 as a logical 1, and remaining D0 and D3 as logical 0. This is for the designing of 4:1 multiplexer. Similarly, we will design it for a carry. So in case of carry, we will get a high output at 1 1 and remaining is 0. So carry is enabled for when you have high output with respect to 3. So in case of this, when select pin is 1 1, then D3 will be set it as logical 1. Remaining D0, D1, D2 will be logical 0. This is the design for your half adder. Next, based on these conditions, whatever we have understood, we will have a reflection quiz where you need to realize a half subtractor using 4:1 multiplexer. Take a 1 or 2 minutes and write a truth table of half subtractor. Based on that, design your half subtractor for 4:1 multiplexer. I hope everybody has written the truth table as well as the design part it. So for example, for this, the solution will be, the truth table is, if you see, for 0 0 difference is 0 and borrow will be 0. For 0 1 difference will be 1, borrow will be 1. For 1 0 difference is 1, borrow will be 0. For 1 1 difference is 0 and borrow will be 0. Based on this, my output diagram will be as such. So in case of this, we have given D0 and D3 to the logical 0, D1 and D2 to the logical 1. Based on the select pin, we will get the difference output. Similarly, next we will have one more reflection quiz where we need to design for the borrow. Then moving on to the next, similar to the difference, the borrow figure will be like this, where D0, D2, D3 is given to logical 0 and D1 is given to logical 1. Next application of multiplexer is full adder using 8:1 multiplexer. If you see the truth table of full adder, where you have sum which is enabled for 1 2 4 7. So for this to design, what we do is we connect 1 2 4 7, that is D1, D2, D4 and D7 to the logical 1, remaining inputs to the logical 0. Based on the select pin, the sum output will be given. Next, similarly to sum, we will design it for the carry. In case of carry, it is enabled for 3, 5, 6 and 7. So in case of this, whenever the output is 3, 5, 6, 7, that has to be logical 1. So for that, D3, D5, D6 and D7 is connected to logical 1, and D0, D1, D2 and D4 is connected to logical 0. So based on the select pins, output will be given to the carry. So based on the whatever we studied for full adder, we have to design our full subtractor. So take a reflection quiz where we have to realize the full subtractor using 8:1 multiplexer. For that, first you need to design the truth table, then later we'll move on to the circuit diagram. Take a 1 or 2 minute and design for it. I hope everybody is done with the truth table as well as the circuit diagram. Here is a solution for it. The truth table for 8:1 multiplexer for full subtractor is where difference is enabled for 1, 2, 4 and 7, and borrow is enabled for 1, 2, 3 as well as 7. So circuit will be based on the difference value, that is 1, 2, 4, 7 is enabled. So difference circuit is like this. In case of this, D1, D2, D4 and D7 is connected to logical 1, and D0, D2, D0, D3, D5, D6 is connected to logical 0. Similarly for the borrow, we design, in case of borrow, we need high enable output for 1, 2, 3, 7. So based on that, the design is D1, D2, D3, D7 is connected to logical 1, remaining are connected to logical 0. So I hope everybody understood some of the applications of multiplexer and reflection quiz. Thank you.